Um, Thank you for the introduction. Hi, everyone. I'm Wojtek, and today I'm going to talk about Hex. And when I was asked whether I wanted to give a talk about Hex, one of my very first thoughts was like, isn't Hex like 10 years old already? And I am a pretty sentimental person. 10 years is a pretty round number, so I couldn't get it out of my head. And so that is the talk. What has been going on in the last 10 years? And 10 years is a lot of time, so it is going to be pretty subjective, but I hope you will find it interesting anyway. Quick word from the sponsor. I work at Dashbeat. We help companies run Elixir in production, and I'm very happy to say that we are spending a lot of time on open source, most of the time on open source. So let's talk about Hex. In a way, Hex is a few different things. It is hex.pm, the website, and it says right there, it's the package manager for the Erlang ecosystem. And on the website, you can browse packages, there is some documentation, and we can sign up and publish our own packages. Hex is also an API. We publish packages through the API, and then we can have programmatic access to browse packages or build tools on top. Hex is also a set of specifications. We document all of the endpoints and formats so that we can have different Hex clients talk to different Hex servers. So Hex clients would be usually build tools, and Hex servers would be the official one, but you can also run your own, like a maybe internal company server. And we have these specifications so they can talk to each other, so they can follow some specification and they can interoperate. We have Hex for Mix, Hex for Rebar 3, and then we have Hex Core. And Hex Core is a library. It's, we would say that it's a reference implementation of the Hex specifications written in Erlang, and it is used by some build tools. But you can also use it as a dependency to build something on top of Hex. And then we have Hex Repo, which is the endpoint where the package tarballs actually live. We download it from Hex repo, and we also have registry files, so kind of like index files to efficiently store some data that we can then use for dependency resolution. We also have Hex Docs. It is a documentation hosting service by the Hex team. We also have Hex Builds, Diff, and Preview, which we are going to talk about soon. And then we have the people behind the project, so the Hex core team. So that is Eric Meadows-Jönsson, Todd Razudek, and myself. And yeah, I was looking for some, first things about Hex. I found this commit on GitHub by Eric. So that is December 23, 2013, so more than 10 years ago. And it was made by Eric. He's the creator. He put by far, not even close, the most work and still does on Hex. So thank you, Eric, if you're seeing this. And maybe half a year later or so, Hex was officially announced as part of Elixir 0.13, so before 1.0. And just to give you an idea, this is the release, Elixir release, which added for the first time maps and structs. And maybe half a year later, we had big release. There was the big release Elixir 1.0. The language was considered stable. And maybe a month later, so that would be still 2014, there was a very small, insignificant, but pretty dear to me. It was a commit by yours truly. It was just like a random one-line change to the README. But this was the very first commit that I ever did to something related to Erlang. And it was, I did say that I'm a pretty sentimental person. So it was October 11th, 2014, which is 10 years and 3 days ago. I couldn't possibly imagine that 10 years later, I would get to be on the stage giving a keynote. It's pretty wild. All right, so some more Hex news across the years. In 2017, we added Hex private packages. So if you want to use Hex tooling, but you don't want to make your packages public, you can submit them there. This also helps offsetting some of the maintenance costs. as this is a paid service. And then we announced Hex Core in 2018. So in hindsight, maybe the Erlang implementation should have been there from day one, but I actually kind of like that we have both the specification and then the reference implementation because they serve different purposes. Like maybe if we had the reference implementation, maybe we wouldn't quite put enough work into the spec. And the spec is important because tools outside of Erlang can use it. So for example, the GitHub Dependabot is, the specification is probably useful to them to integrate with Hex. And for example, Gleam also integrates with Hex. There is the integration written in Rust. And so hopefully the specification was helpful there. Oh yeah, and then again, you can use Hex Core to build tools yourself on top of Hex. In 2019, we had Hex 020, so we added organization-managed public packages, but I wanted to focus on one other feature, which is we added package diffing. So in that release, so the tarballs are public, the URL is well specified, but we added a convenience way to quickly download package tarballs. So we can just do, let's say, mix hex package fetch decimal. We can also pass the version, and that will download the tarball. And we can even pass unpack flag, so it will unpack it so we can see the package contents. And this is very important for security, for authenticity purposes. Most people would host their code on GitHub or GitLab and then publish to Hex, but you know, this may not necessarily be, like usually it would be the same code, but you know, well, there was like the XZ fiasco thing, so it is very important to build tools to audit, and we think we can help people this way see what they are downloading and updating to. And so we also added the diff command, so we can give a package and version range, and right there in the terminal we can see a diff of what is changing. So this was pretty well received by the community. And in fact, a community member, Johanna Larsson, built this Hex diff as a service. It was a proof of concept, and then she even submitted a very well-written proposal to make it as part of Hex, and she did all of the work. We just helped with some minor stuff and then the hosting. And then in 2020, we announced Hex diff. So this is like the first sort of service in the Hex ecosystem, kind of a little bit outside of the main app, but still part of the project. So we can go to diff.hex.pm, find a package, and then choose the version range. And right there, we can see the diff. And this is great because it is on the web. We have the URL, so we can share the URL, build some automation on top, which is, again, I believe, very important for security. And then Todd Razudek from the core team added a similar service down the road, so Hex preview. And again, we just go to preview.hex.pm, we find a package, we find some versions, and then we see the package contents. We even do some light syntax highlighting. And again, we have the URL, so we can share it with people. Example package page. So for the decimal library, when we scroll down, we see all of the releases. And for each release, we have these three little icons. So documentation, diff, and preview. In Hex 021, we added some improvements to self-hosting and to diff. So about self-hosting, like since we had the specifications from the early days, you could self-host, but you kind of had to read the spec and write all of the code or copy it from Hex. So when we added Hex Core, that was a significant improvement because we already had some functions in Erlang to build registry yourself, but maybe you wanted to build it in a different language, or maybe you didn't want to bother gluing it together. So we added mix hex registry build, which is a single task to build a local registry. You only need a private key and then like a folder. And then, you have some files that you then just host on the web, and you can interoperate with Hex clients that way. The other improvement that we added in that release was around diff and dependencies. So since the very first, the early days, we had the hex outdated task. So when we run it in a project, we can see all of the dependencies, and if they could be updated, we would let you know. And here, for the Finch and JSON library, we have some updates possible. So the improvement in this release was at the bottom of the output, we have this: to view the diffs in each available update, visit this URL. And when we go to that URL, and again, it's a URL, we can share it, we can build tools, we can see links to diffs for the version that is in your project, and then to what you could update to and see what has been changing. And in December 2021, we announced Hex 1.0. There wasn't any like a major feature or at all, but it was a promise of stability and compatibility. So Hex always was compatible with Elixir going back to 1.0, and that was kind of solidified in Hex. So it was compatible with Elixir 1.0, and the idea was that Hex 1.0 will always be compatible with Elixir 1.0, but we want for newer releases to have kind of freedom to use more recent Elixir and then OTP features. So that was announced in Hex 2.0. So Hex 2.0 is not compatible all the way back to Elixir 1.0, but it is still very, very conservative. So I'm sure you'll be good. And then in that release, we also announced a new version solver, improved performance, and error messages. So this is actually all about kind of Hex itself. There is a ton of, in my opinion, interesting technical details and maybe the security model. And I'm very happy to talk about all of that during the conference. But I wanted to use this opportunity to talk about maybe kind of Hex adjacent things that might be interesting to you. So builds. Since the very early days, we had lovingly named project Bob the Builder as part of the Hex project. And Bob is an Elixir service that performs some automation tasks to help with the Elixir and Hex maintenance. So Bob builds Elixir, it creates the precompiled, or it did create precompiled Elixir releases and Elixir docs. Now we actually moved some of that work to GitHub Actions for the Elixir repository, so you can kind of see how it is being built, and if there are any build errors, you can see them yourself. But Bob this since the early days, and it did publish the documentation. Again, we now publish documentation off of GitHub, and Bob is still building Erlang builds. So the Hex team maintains OTP builds for Ubuntu. We support the LTS, long-term supported releases. And we have releases for AMD 64 and ARM 64 architectures. And we also have Docker. We also maintain Docker images. So briefly about the Docker, it is very cool that we can just run this and it just works. We would get an Erlang, but that's the thing. We would get an Erlang. We don't really. We will get an Erlang that is latest at the moment we run this command. And if we do this, like a month later or a year later, we'd get a different version. So we can pin a version, but this is not quite still enough, because this tag 27.1 would be automatically kind of updated, mutated when 27.1.1 is released. And so there is, of course, backwards compatibility, but there could be unforeseen issues when we we got something that we didn't exactly specify. And then there is also the operating system under the hood that also keeps changing. So for us, we have the same thing with Elixir. We can pin like Elixir 173 OTP 27, but again, if there is a new OTP version and we would use this Docker image, we could get something different than we expected. So this is where the Hex Docker images come in. We publish images with exact versions. So here we have Hex PM Erlang. 27.1.1, and then exact version of Ubuntu. And this tag is never going to be changed. This is immutable. And then we have the same thing for Elixir. So the exact version of Elixir, of Erlang, and of operating system. So this was very well received by the community. I think it solved a real problem that people had, but there is maybe a little bit of a caveat. So we have to have these versions available, we need to pre-build all of them. So for Erlang, if we count the tags, or if you get the information about the count from Docker Hub, for Erlang we have 8,000 Docker images. Well, wait until you hear how many Elixir images we have, because we have these and then times all of the possible Elixir versions, right? Like we have this explosion of combinations. So you could pick exactly Elixir and Erlang and operating system for you, but yeah, there is 150,000 of these. So we were solving a real problem, but I think it is maybe not the optimal solutions. So we have some ideas to still allow you to specify exact versions, but maybe kind of get the builds more on demand, because the reality is not all of these are being used. So yeah, we have some ideas, but but nothing to announce quite yet. And so we have the Ubuntu builds from Hex. We have the OTP team maintains Windows builds. So we have these operating systems covered. And then I'm a Mac user, and we didn't really have precompiled OTP. There were some community projects, but I tried kind of rallying the community together and sent a proposal to have community maintained OTP builds as part of the Erlang Ecosystem Foundation. So I sent the proposal, I implemented the project and all of the automation. I didn't quite finish yet before the talk, but it is going to be announced pretty soon. And so here we support macOS, and then again AMD 64 and ARM 64 architectures. And the goal of these builds is to be as self-contained as possible. So Erlang depends on SSL library and optionally on WX widgets. So we statically link them, so you don't have to have them installed on your system. It's just going to work on a brand new operating system. So you don't have to install anything else. You should be able to just get started. And down the road, I would like to move the Ubuntu builds to this project. So again, they would be built on GitHub Actions, so there's more visibility into any potential build issues. And the way we do it is, on that repo, we create GitHub releases that follow the OTP releases, so the tags are matching. And we do this GitHub releases so we can attach assets, build artifacts to those. So these are kind of concrete URLs that you can download these builds from. And a cool thing that we did is we even track the maintenance branches. So there is like a special release, maint latest. And this release, so this is actually maybe kind of ironic that I said it's kind of bad that Docker tags that are mutable, and now we kind of added a mutable release, but I think it's pretty clear that this is supposed to change. This is updated as the maintenance branch of OTP is being changed. And then we have another one for the master branch. And recently we did something similar for Elixir. So we have a main latest release that follows the main branch, and there are precompiled builds attached to this release. So I wanted to briefly talk about the docs. And to me, when I was just starting with Elixir, this was, and still kind of is, one of the, I don't know, favorite aspects of it, the quality of the documentation and then tooling. And so this is using Xdoc, and one of my kind of favorite feature is that just kind of like finding links and like, so we can hover over links, so get a sneak peek and kind of, you know, we can click through and go down the rabbit hole. I tend to do that with Wikipedia sometimes, and you know, if you know, you know, right? One of my favorite features is to have docs available in the shell. I guess like since last 5 years or so, something, we tend to have documentation in the editors, but yeah, I still use them all the time in the shell. And so we can just find a module or function and get the documentation right there in the shell. And so spoiler alert, we have that in Erlang as well, but that was not always the case. So I found back in 2016, Radek Szymczyszyn added a third-party project to add ability to see Erlang docs in the shell. And then a couple of years later, the kind of community rallied about some standardization effort. So there was EEP 48, documentation storage and format, a proposal. So EEP, Erlang enhancement proposal. And I'm just going to read out the abstract. So this proposes an official API documentation storage to be used by Beam languages. By standardizing how API documentation is stored, it will be possible to write tools that work across languages. And I really love the last part. We have a standard that is then being used by the greater Beam community. And then down the road, Lukas Backstrom from the OTP team implemented the proposal in OTP, and he added the shell docs. So since then, they are available in Erlang. And then a year later or so, in 2021, José Valim sent another proposal to have module attributes for documentation. And again, from the abstract, the idea is that the documentation is handled as part of the language parser and included directly in the compiled Beam files as a replacement of edoc-style comments. And Python, Elixir, and Clojure are examples of languages that follow this approach, approach of treating documentation as data as opposed to code comments. And here's an example from the proposal. We have a module doc attribute, and then we have data, the string of documentation. And Kiko Fernandez from the OTP team implemented the proposal. And Lukas Backstrom, again, helped with the documentation effort. In one PR, he changed all of the existing OTP XML documentation into Markdown and into these module docs, and it was a cool couple 100,000 lines change. And that was not even it. If that wasn't enough, in the same proposal, he made it so that from that moment on, OTP was using Xdoc for documentation, which as an avid user and maintainer of Xdoc, I gotta say it was pretty nice moment that we have this tool that kind of, I don't know, kind of came back all the way to OTP. And again, we have a ton of features in Xdoc. And the thing is that now, whenever we add a new feature to Xdoc or like a bug fix or enhancement, it can potentially have huge impact because then it will be used for Elixir docs, OTP docs, and package docs as well. So if you want to make a huge impact, you may consider contributing to that. I wanted to talk about a couple packages in particular, which is kind of impossible task because there is literally almost 20,000 packages. So this is going to be extremely subjective, but I wanted to talk about a library called Mint. And this is, to me, this is one of the most kind of influential packages for me personally. And the funny thing is, I don't even use it that much directly anyway. I use it indirectly all the time. And so Mint was announced on the Elixir blog, a new HTTP client for Elixir. And from the blog post, the idea was to provide a small and functional core that others can build on top. Mint is connection-based. Each connection is a single struct with an associated socket belonging to the process that started the connection. So there is no connection pool. Since no extra processes are started for the connection, you can choose the process architecture that better fits your application. So the idea with Mint was to be included in Elixir and then used in Hex. And we have this kind of interesting design constraint with whatever we want to use in Hex. In Hex, we cannot really have dependencies, kind of like a chicken and egg problem. So whenever we bring something in, we can vendor it, but we need to prefix the modules so that there is not going to be a conflict if you want to use something as a dependency, right? So like hex core, for example, we use hex core in hex, but we copy we vendor all of the modules and we prefix them with mix. So there's like a mix hex core. Because again, you may want to be able to use hex core as a dependency with a potentially different version. So it was a kind of an interesting design constraint for hex core and also a design constraint for Mint that it is not going to have any processes or any kind of global state. Yeah. And then so usage example of Mint, we connect to a server and get a con struct back. So in the con struct, we have there is some internal data, and then basically all Mint functions return the con. So when we make a HTTP request, it returns updated con and a request reference. And then by default, Mint uses sockets in the so-called active mode, meaning the network data comes back to the calling process as Erlang message. So here we receive the message, and then we print the message, and then call Mint stream, which parses the message and into some structured data. And then at the end, we can inspect these structured response parts. So the message is the standard GenTCP tuple, the TCP atom, the socket, and then the data. And the structured data that was parsed is a list of tuples. The structure is always tuples, where the second element is the socket. The second element is the reference, the request reference. And the idea is that from a single process, we can make many requests. They come back to the process that was making them, and we want to be able to reference them back to the request that made them. Mint, I think is, in my opinion, it is at a very nice level of abstraction. So we have the GenTCP socket, generic TCP socket, and then we have Mint just above GenTCP to implement the low-level details of the protocol. So I really like that. It is pretty verbose, but I think that's okay. If it would be up to me, I would make it as part of Elixir, so it is available. And well, if it would be up to me, I would even build it into OTP. Maybe it's good that it's not up to me. Maybe it's not. But I think there is something to it, though, that like even the name, right? Like Gen HTTP, generic HTTP socket. You can build anything on top of that. You can bring your own process architecture that makes sense for your application. And HTTP, just saying HTTP, pretty useful protocol, pretty popular one. Yeah. So just kind of random anecdote. When I first joined Dashbeat, one of my first projects was writing a new MySQL adapter for Ecto. And whenever we have Ecto adapters, we use the DB connection library by James Fish. So DB connection gives us callbacks to implement, and it handles all of the hard stuff, which is queuing, queries, and doing all of the process management. So as a driver implementer, you just need to implement these callbacks. So usually what we see is in the DB connection implementation module, we interact with the socket directly, and so that's initially what we did in MySQL. And then Mint was maybe out already, or it was being released around the same time. And I did mention that it influenced me. So what I ended up doing was to move all of the socket stuff into a separate module, which I think greatly, it is subjective, but I think it improved significantly the design of the library. In a separate module, I did kind of like a single process, sequential code, interacting with the protocol, and then all of the interaction with the DB connection, all of the pooling and process management was kind of somewhere else, and it was orthogonal. And we didn't do that, but I wish to make a similar refactoring to Postgres one of those days. to extract the socket part. And again, ideally, in ideal world, in my opinion, we should have something like Gen Postgres. Definitely not part of the OTP, but I think even like if we write it in Erlang, then this is available across the ecosystem. Then Erlang can use it, Gleam can use it, but even the names I think are interesting. So here is a Postgres client, and here is a generic Postgres socket. And the generic part, I think is kind of interesting. Like it's not necessarily just client focus. Ideally, I would make it so that it supports both the client and the server end of the protocol. They tend to be symmetrical. And if we had something like this, then we can very easily build like, so again, maybe this is like, if you happen to write database drivers, it is kind of nice to have like a way to simulate a database server all the way back on the wire protocol. So that would help for testing. But even for debugging, if we were able to have both ends of the protocol, we could easily build a Postgres proxy that would take some traffic from the client, then decode, and then we would have like the packet, the low-level packet as data, and then we can maybe change the data a little bit and then send it back. So very useful for debugging. And you could rightly so say that like, okay, so maybe this is better design, objectionable. Maybe this debugging proxy is kind of neat, but like, is this really useful in the real world? And I would argue it is. And as a matter of fact, there is a cool project from Supabase called Supervisor, and it is a cloud connection puller for Postgres. So from their announcement, Supervisor is scalable cloud-native Postgres connection puller. It has been designed with multi-tenancy in mind, handling millions of connections. And the architecture is exactly like that. There is a proxy in the middle between clients and the actual servers. The proxy accepts a connection from a client, holds onto that connection, and then they do some custom authentication and other parts. They do implement that part of the protocol themselves. And then Supervisor holds connections to the actual downstream database servers. And I believe a library like Gen Postgres or something along those lines would greatly help projects like that. And in this particular case, they use it at scale. So whenever they improved a low-level piece like that, we could all benefit of them running it at scale. I very briefly wanted to mention one other package, which again, I'm not really a user. I'm a happy user of kind of dependent libraries. So that is Rustler. And Rustler allows us to write nifs or natively implemented functions. When I write nifs, it means naively implemented functions. And so with Rustler, we can just write some Rust code, add a little bit of annotation, a little bit of boilerplate, and then we basically that's it. We now can call Rust code from Elixir, and Rustler does all of the boxing and unboxing of values between, like, let's say, the Rust world and the Beam. So this is very useful. Turns out there is already a ton of Rust code that we want to be able to tap into. And here is an example, Explorer. Explorer brings series, so one-dimensional, and data frames, two-dimensional data for fast exploration in Elixir. Explorer uses the Polars Rust library and uses Rustler to integrate with that. And then we have, on each Explorer release, when you scroll down, we have a bunch of these build artifacts so that you don't even have to have Rust toolchain to use Explorer. When you install Explorer, it will download these builds, the build that matches your operating system. And by the way, again, we have these precompiled builds. Like there is, I don't know, I think that's the thing, like precompiling these builds for like these different targets. And I don't know, it tends to keep coming up in the sort of work that I do. And I don't really have a plan yet, but I think we can maybe do something on Hex side to make it easier to use. And again, maybe have these kind of not necessarily precompiled for every possible target, but do like on demand, which would be very useful, for example, for nerves. Like we have a bunch of different architectures for nerves. I don't think it's necessarily feasible to precompile everything, so it would be nice to be able to precompile on demand. This work that we have these precompiled releases, my colleague Philip Sampaio created a project Rust precompiled that adds tools to make it easy. And another similar library to Rustler is Ziegler. And this allows writing nifs with the Zig programming language. And Zig is actually very, very interesting. I think it is still pre-1.0, but I think it has amazing potential. One of the coolest things that I think about Zig is that it is simple. Like the syntax is simple. It they try to keep it simple. I kind of miss the barrel checker, I gotta say, but it is still pretty nice. And what I think is very nice about Zig is that it has amazing interoperability with C, and it has cross-compilation. It has like best of the league cross-compilation features. And actually what you can do is you can take some Zig code and some C code and cross-compile it to pretty much any target, which I think has some interesting potential for the Beam tapping into greater C ecosystem. And Ziegler, similarly to Rust, here it's even simpler. We can just even write inline Zig, and it just works. And Ziegler handles all of the boxing and unboxing. One of the features that appeared throughout the years is mix install. And it totally feels like something that should have been there from day one. So just an example, we can open up IEX, and then, sorry for the plug, but I created a little HTTP client called rec, and we can just mix install rec, and now it downloads, it compiles right there in the terminal. And with rec, we can just, so we can call a GitHub API to get information about rec itself, and it would return a struct, so we can take the body, access the body, and then this is a JSON API, so when rec sees that, looking at the content type, it will automatically decode it, so you can access that, and you have the tagline, so a battery is included, HTTP client. And my idea with rec was to be easy to kind of experiment with stuff, to build prototypes, but also to be suitable for production. And I think basically since mix install came out, I have seen more focus, a little bit more focus for libraries to be kind of mix install friendly, if that makes sense. You just mix install something and just call 1 or 2 lines, and that's it. So mix install is an Elixir feature. So, but what about Erlang? Well, what about it? We can just call mix install in Erlang as well. We have to do this weird Elixir prefix. Yeah, there is a whole thing why that is needed. But yeah, mix install rec. Mix install is caching the downloads and compilation, so you don't, so we don't do any extra work. And then we can again call the same endpoint, and we're going to have the same result. Now, mix is not. Oh, and another thing is we can mix install anything, and then again, because we have that implementation of the documentation storage format, we can see rec docs right there in Erlang shell because we have that interop. And the way it works is I have a .erlang file which does the following. I just find executable of Elixir, get like the root directory of Elixir, and then add Elixir, mix, and logger ebin files to the code path, so then these modules can be discovered by the shell. And then, as an example, we can mix install telemetry, which is an Erlang library. So again, it just downloads and compiles it. And we can see the documentation of telemetry, not built into OTP, of dependency as well right there in the terminal. So this works only as of the latest version of telemetry. And the reason is Andrea Leopardi changed all of the docs to use the new module attribute and markdown. And so we have this module doc macro. And the reason it is a macro is so that after OTP 27, which added module attributes, the macro expands to this module doc. And we still want to be able to compile it for older releases, so it's a no-op there. I maintain a mixed install examples repository. There is at least 60 or so single file scripts. People said it's a great resource to see what you can do with the Beam. I very briefly wanted to mention Livebook. It's an interactive and collaborative code editor. We can write some code and then see the results right away. We can hover over things. We would get documentation. Again, we have that documentation standardization effort, and this is one of the ways it pays off. And we can autocomplete stuff as well. And we can even add more code cells. We have some basic support with Erlang. It keeps getting better with every release, but it's still not quite there. And then we have a bunch of smart cells. So different things that you can do with it. Go to livebook.dev if you haven't, and we can even have something called Livebook Desktop, which is kind of like a distribution of Livebook tailored for desktop operating systems. It actually supports all of the operating systems as long as they're called macOS or Windows at the moment. We want to add Linux support down the road. And then, we can do graphing, we can do connections with different services right there in the Livebook. And one other thing about that Livebook desktop, we made it so that it uses these precompiled OTP releases. Everything is statically linked. Again, this keeps coming back in my work for some reason, that you just download a Livebook desktop and it just works. You don't have to install anything else. And again, about installing, I added, so we have many different ways of installing Elixir, but I still think we can do a little bit better. So I created this project, and so what we can do is download a single file, install shell script, and then call it. We can even pass exact versions of Elixir and OTP, and under the hood, it downloads OTP for the operating system that you're on, and then Elixir, which is cross-platform. And then there are instructions so it downloads it into a location and instructions to add it into your path, and that's it. And again, this OTP is pre-built, everything is statically linked, and so Elixir install works on all operating systems as long as they are called macOS. And we support Windows, and we support Ubuntu, and as we will have more precompiled statically linked OTP for other operating systems, they will just work here as well. And because we have these main latest kind of releases that follow the branches, we can even do this and it just works. It's not going to compile anything, and you can check the latest Elixir, the latest OTP, and see what's new. I sent a proposal to make it kind of official, so stay tuned for that. And then worth mentioning, there is a kind of similar project, a Beam app from Tristan Slaughter from the Rebar team. It is way more ambitious, definitely bigger scope. It allows to install Erlang and Elixir and Gleam and maybe others as well. It does like all of the version management as well. So much more kind of ambitious. I definitely root for Beam app. And I'm running out of time, but I very briefly wanted to mention top 10 packages by silly metric, which is recent downloads, but it gives a signal what people tend to use. So top 5, to surprise of no one, at the top is a JSON library, and as of OTP 27, it is going to be slightly less needed because JSON is now built in. And at number 4, we have SSL verify fun. That is also no longer needed since I believe OTP 25, where there have been great SSL improvements, kind of like safe SSL defaults. And then number 7, certify, kind of no longer needed since OTP 25. OTP has access to the built-in certificates. And then there is Unicode util compat, which like it even says that it's just for OTP prior to 20. So out of top 10 packages, 4 of them, we don't even really need them anymore because we see the constant improvements of OTP, which I think is fantastic. And I wanted to leave you with this quote by Bill Gates. So most people overestimate what they can do in 1 year and underestimate what they can do in 10 years. What a wild 10 years it has been, and I cannot wait for the next ones. Thank you so much.